Hello friends, now let us start with a few examples on Laplace transform, that is find Laplace transform of following signals. So the first one is an impulse function given x of t is equals to del t. We'll put those formula. We know that Laplace transform is minus to plus infinity xt into e raised to minus st dt. Now we'll put this value of impulse function del t exponentially into dt. Now we know the property of impulse function. Impulse function exists for a single value, that is del t is 1 for t is equals to 0, otherwise its value is going to be 0. That means there is no point of integrating it. So we'll just put the value of t is 0, this becomes 1 and e to the power 0 becomes 1, and by that we can write Laplace transform is equals to 1. Now let us consider the second example. X of t is equals to u of t, that is unit step signal. So we'll get xs is equals to integration. Now I'm simply writing u of t e to the power minus st into dt. Now whenever we will find u of t, unit step signal, limit will change from 0 to plus infinity because it exists for those values, 1 into e to the power minus st dt. Integration of this we can write e raised to minus st upon minus s over the limit 0 to plus infinity. Now minus 1 by s will take outside. Upper limit is infinity, though it is plus infinity, it is multiplied with minus sign. So this is e raised to minus infinity minus e to the power 0. Now again e to the power minus infinity, that value is 0, and e to the power 0's value is 1. So this minus and minus becomes plus. So its result is 1 by s. So Laplace transform xs is equals to 1 by s. Now we'll see the third case is to find Laplace transform of cos omega naught t. So I'm writing third one, xt is equals to cos omega naught t. Now basically when you are finding Laplace of cos or sine, try to take unilateral transform. So we'll write xs is equals to now 0 to plus infinity xt e to the power minus st into dt. So we'll put the value of input signal, which is cos omega naught t e raised to minus st into dt. Now if you want to integrate this, the best method is try to convert cos, or try to write cos in terms of exponential function. We know that cos theta is e to the power j theta plus e raised to minus j theta divided by 2. So we'll write this in terms of exponential function. So this equation holds 0 to plus infinity. Angle is now cos omega naught t. So omega naught t is the angle. We'll get this term e to the power j omega naught t plus e to the power minus j omega naught t divided by 2, and it is multiplied with e to the power minus st dt. Now we'll try to multiply e to the power minus st with this. We'll get 1 by 2 outside. Integration, first term e raised to j omega naught t into e raised to minus st dt, plus next integration term 0 to infinity with a minus sign, e raised to minus j omega naught t e raised to minus st into dt. Now next step we'll try to take the common terms. So 1 by 2 as it is. First integration term 0 to infinity. Base is same. If I want to add the power terms, we can add them. E raised to, if we take minus sign as common, we'll get this term s minus j omega naught t into dt plus 0 to infinity. Again if you take minus sign from both this term, this is s plus j omega naught t into dt. Now we'll integrate this 1 upon 2 as it is. Integration of this e raised to minus s minus j omega naught t divided by minus s minus j omega naught over the limit 0 to infinity plus e raised to minus s plus j omega naught t upon minus s plus j omega naught. again the limit is 0 to plus infinity. And both the terms, if you observe this this term, we'll take minus 1 upon s minus j omega naught into, putting those values, upper limit is infinity, we'll get e raised to minus infinity minus e raised to 0, and from that minus 1 upon s plus j omega naught into this term, again e raised to minus infinity minus e raised to 0. Now this value is 0, this is going to be 1, this is 0, and this is 1. Finally we'll write them 1 by 2 as it is. This minus minus becomes plus 1 upon s minus j omega naught. Now this is again a minus sign and this is again a minus sign, so this becomes plus 1 by s plus j omega naught. Now it remains with just a cross multiplication. We'll get 1 by 2 into cross multiplication of this s plus j omega naught plus s minus j omega naught divided by, now this is as good as x minus iy into x plus iy, so its result will be x square plus y square. I'm writing it here, x minus iy into x plus iy will be real part square plus imaginary part square, so denominator becomes s square plus omega naught square. From numerator this j and this will get cancelled, this remains with 2s and this 2 will get cancelled. Finally we are left with s divided by s square plus omega naught square. So this is the Laplace transform of cos omega naught t. Now let us say the next one, x of t is equals to sine omega naught t. So now again we'll consider xs is from 0 to infinity, sine omega naught t e to the power minus st into dt. Now we'll try to put this in terms of exponential. Sine theta is always e to the power j theta minus e to the power minus j theta, so you can write e raised to j omega naught t minus e raised to minus j omega naught t divided by 2j into e raised to minus st into dt. I'm writing it here, sine theta is e raised to j theta minus e raised to j theta divided by 2j. Now we'll again take 1 by 2j common, 0 to infinity, multiplication of this e raised to j omega naught t e raised to minus st minus 0 to infinity e raised to minus j omega naught t e raised to minus st into dt. We'll again make the same process. We'll take minus sign as common, so we'll get s minus j omega naught t dt minus this integration. If I take minus sign, this is s plus j omega naught t into dt. Now we'll integrate this, 1 by 2j remains same, integration of this e raised to minus s minus j omega naught t upon minus s minus j omega naught, the limit is from 0 to infinity, and this term e raised to minus s plus j omega naught upon minus s plus j omega naught, limit is again 0 to infinity. So in next step also 1 by 2j as it is, this is minus 1 by s minus j omega naught into, now if you see the upper limit is infinity, this becomes e raised to minus infinity minus e raised to 0, this minus minus becomes plus 1 by s plus j omega naught, putting those limit e raised to minus infinity and this is e raised to 0. Now the same step, these terms are going to be, this is 0, this is 1, this is 0, and this is going to be 1. So we are left with the values that we can write directly now. This is 1 by 2j outside, so we are left with 1 upon s minus j omega naught, and this is minus 1 by s plus j omega naught. So we'll write directly 1 by 2j as it is, s plus j minus s plus j omega naught, this minus sign changes the sign, and divided by as usual s square plus omega naught square. So this plus minus get cancelled, 1 by 2j into 2j omega naught addition of these two upon s square plus omega naught square. So j, that is 2j will get cancelled, and this Laplace transform becomes omega naught upon s square plus omega naught square. So this is the Laplace transform of sinusoidal function. Now let us see some examples by using properties of Laplace transform. So the fifth question I am writing, let x of t is equals to u of t minus 2. Now this signal is u of t is shifted by 2 units. So we'll use time shifting property. I'm writing that statement. Laplace transform of x of t minus t naught becomes, now this is shifted by t naught units in time domain, so it results in the same delay in the output side, e raised to minus s t naught into x of s. Now to find Laplace of this, first we'll determine Laplace of u of t. We know that Laplace of u of t is 1 by s. Now if it is shifted by 2 units, so this becomes e raised to minus 2s. So we'll write Laplace of u of t minus 2 is, the delay is of 2 seconds or 2 time, so we'll write e raised to minus 2s into x of s is 1 by s. Therefore it becomes e raised to minus 2s upon s. So this is by time shifting property. If the time permits, we'll try to make another lecture on properties of Laplace transform. Now the next question and foremost important is x of t is equals to e raised to minus alpha t cos omega t into u of t. We have to find Laplace of this function. Now we have determined already the Laplace of cos omega t with u of t, unilateral Laplace transform. Now it is shifted with some delay, so we'll use a property called as shift in s domain property. The statement is, if I shift in s domain, that is s minus s naught, that results with the same term as e raised to, this is shifted by s naught, so this is e raised to s naught into x of t. That means we can say that Laplace of x of t with exponential becomes x of s minus s naught, that is shift in s domain property. It is a counterpart of time shifting property. Now by that case, first we'll try to determine Laplace of cos omega t into u of t. So we know that Laplace transform of cos omega t into u of t is nothing but s divided by s square plus omega square. Now the change is what? It is multiplied with, you can see this input signal is multiplied with minus alpha. If s naught is positive, this is minus, and if s naught is negative, it definitely will be plus. So by that case, we can write Laplace of e raised to minus alpha t cos omega t into ut should be equal to, so wherever we will find s, replace it by that delay, so it becomes s plus alpha divided by s plus alpha whole square plus omega square, that is nothing but s plus alpha upon s plus alpha square plus omega square. So this is the Laplace transform of e raised to minus alpha cos omega t into u of t. Now remember this property. The change is what? In time shifting, x of t minus t naught's Laplace becomes e raised to minus s t naught into x of s. Now in case of this property, we are shifting in s domain, so this is e raised to minus, so this becomes e raised to plus, shifted by s naught t, and input signal is x of t. So this is the difference between time shifting and frequency or s domain shifting property. Now let us see the next example, that is on sine, e raised to minus alpha t sine omega t into u of t. Same step, first find Laplace of sine omega t, which is omega by s square plus omega square. Now this input signal is multiplied with the exponential function, so you can write Laplace of e raised to minus alpha t sine omega t into ut becomes, wherever s is there, replace it by s plus alpha. So numerator omega as it is, denominator becomes s plus alpha whole square plus omega square. So this is the Laplace transform of exponential with sine omega t into u of t.